Hi guys, I want to talk about factoring out the greatest common factor. That's what GCF stands for, greatest common factor. I've talked about this in a previous video, but I wanted to talk about it again, go into more detail, hopefully clarify anything that we're still having trouble with. So factoring out the greatest common factor. So we're going to be looking at starting with number 4 here. So the first thing I'm doing when I'm trying to factor out the greatest common factors, I'm going to look at my numbers and I'm going to say, okay, what do these numbers have in common? What if I broke these numbers down into their factors, right? What would they have in common? So for example, 21 is 3 times 7. 21 is 3 times 7. 30 is 3 times 10. So they all have 3's, right? They're all divisible by 3. So that's what I'm asking myself. What are all of these things divisible by? They're all divisible by 3. So that is going to be the first thing. One of the things I'm going to factor out is going to be a 3. So I'm going to write that here to remind myself. It's going to be a 3. Then I'm going to look at the variables. What variables do these all have in common? Well, they all have A's. They all have A's. So I'm going to factor out an A, but I have to figure out what power I'm going to factor out. So the power is always going to be the lowest power that I have. So, right, if I factored out an A to the 9th, then I'd have negative exponents here, and I don't want that. So I'm going to factor out the smallest power that I have. In this case, that's going to be 5. So I'm going to factor out an A to the 5, A to the 5th. So that's what I'm factoring out. Once I figure that out, then I just need to divide each one of these by this. So I'm going to divide by 3a to the 5th. So 21 divided by 3, right, is 7. And then a to the 9th divided by a to the 5th. Remember, we're just subtracting our exponents, right? We have the same base, so we can just subtract our exponents. So 9 minus 5 is 4, so this is a to the 4th. And then we continue. So we're going to do the same thing, just dividing by 3a to the 5th each time. So again, 21 divided by 3 is 7. This is being subtracted, so I need a minus here. So 7, and then a to the 6th divided by a to the 5th. Again, we're just subtracting those exponents, so that's just going to be a to the 1st. So I'm just going to not write the 1. So it's a to the 1st. Plus, I'm going to have the same thing here divided by 3a to the 5th. So plus 30 divided by 3 is 10. A to the 5th divided by a to the 5th is just 1. Those cancel each other out, right? So I don't have any a there. So this is what my final answer should look like. The thing that I'm factoring out goes in front. And then once I divide, those things go here. So the logic here is that if I were to distribute this back through, right, I would be back here, right? If I were just to distribute these, I would be back at my original expression. So this is equivalent. This is equivalent. It's just what we called factored, right? I have factored this. So basically, I split it up into its pieces, right? Like way back in elementary school, when we were looking at finding common denominators, we would break up numbers into their factors, right? So we just meant we were splitting them apart. So like the factors of 21 are 3 and 7. Well, the factors of this expression are these. So one factor of this expression would be 3a to the 5th. Another factor of this expression would be 7a to the 4th minus 7a plus 10. That whole thing is a factor of this expression. So that's what we're saying when we're factoring. So we're splitting it up into its pieces. So let's do another example. Scroll down here. Let's do another example. I'm going to do one of these multivariable expressions. So let's do number 16. Let's do number 16. Okay. So first thing I'm going to look at with number 16 are the numbers again. I want to see what factor do all these numbers have in common. Well, 7 is prime and so is 5. So they really don't have anything in common, right? The only factors I can split this up into is 1 and 7. The only factors I can split this up into is 1 and 5. This I could split up into 3 and 3, but that doesn't really help us because there's nothing that all of these are divisible by. Okay, so I'm not going to have a number that I'm factoring out. I'm just going to have variables, and that's fine. I don't have to factor out a number. If I can't factor out a number, that's fine. I can't factor out a number. So let's look at our variables. They all have x's, okay? They all have x's. So I'm going to have an x that I'm factoring out, but I'm going to figure out what power it needs to be to. So I have an x to the third, x to the third, x to the fifth, x to the sixth. So the smallest power that I have is 3, right? So I'm going to have an x to the third here. I'm factoring out an x to the third, and then they also all have y's. I have a couple of y squareds and a couple of just plain y's. So the smallest power that I have is 1, so I'm going to be factoring out a y to the first power, or just y. So I'm going to be factoring out x cubed y. So x to the third y is what I'm factoring out. So now I need to figure out what I have left. So I'm just going to divide each thing individually by x to the third y. So x to the sixth divided by x to the third, subtracting the exponents. 6 minus 3 is 3, so we get x to the third. Y squared divided by y. Right, 2 minus 1 is 1, so that's just y. Plus, oh, I forgot my 7. So that's the thing to be careful of. Just because there isn't a number here doesn't mean we don't need to take care of this number. So we're not dividing by a number, so numbers are just going to stay the same. We definitely still need to write them. So there should be a 7 there. So then on this next term, again, we're not going to be dividing by a number. So that 7 is just going to be there. It's going to stay the same. So x to the third y. So the number is going to stay the same. So we have 7. And then we have x to the fifth divided by x to the third. 5 minus 3 is 2. So we have x squared. Y divided by y is 1. So it just isn't going to be a y there. Those cancel each other out. And then doing the same thing here, x to the third y. So the 5 stays the same. And then x to the third divided by x to the third, right? 3 minus 3 is 0, so that's just 1. Those cancel, so we're not going to have an x here. And then we have y squared divided by y. 2 minus 1 is 1, so we just have y. And then last one, x to the third y. So we're going to have plus 9 stays the same. X to the third divided by x to the third is just 1. Y divided by y is just 1. So we're not going to have any variables on this one. And that is that. So this is what our answer ends up being. So we have x to the third y times all of this. And if we distributed the x to the third y back through, we would be back at our original. So hope that helps. Let me know if you have any questions on this, and I will see you guys later.